Okay, this is a video recording of Lesson 2 titled Intro to Objects and Classes. In this video, we'll talk about defining our own custom objects in C# as a means of organizing related data, and we'll also talk about attaching functionality or functions to these objects in what we call methods. Okay, so these next few slides are not too relevant for the YouTube video, but I want to mention them in case you are not in the Software Development Tools class, but you're watching this video on YouTube. So most students in this class have taken one programming course prior to this course, and most of those students will be coming from the Python programming language. This is what we teach in our intro programming classes at University of Iowa. So those two facts are going to inform how I'll be presenting the material in this course, and it also gives you a sense of where we are in the learning process of learning to program. So with that, we'll get started with the lesson. So we're still right here in the course here. We're talking about the software developer or programmer role and the tools they will use to help play their part in the software development process. So these are the four tools we're looking at right now, and specifically today we're gonna keep focusing on C# and Microsoft Visual Studio, but right around the corner for our first homework assignment is Azure DevOps and Git. So we might not get to these today, but they're right around the corner. And of course, we'll be adding tools that the software developer will use, but we'll also be learning more about these tools as the semester goes on. It's not like once this lesson's over, we're done learning C#. It's an ongoing process for all of these tools. Okay, so in the last lesson, we had a good in-class question about are all object-oriented programming languages statically typed, or all statically typed programming languages also object-oriented? And that was kind of a signal to me that maybe I was muddying the waters on how these things are related. So I wanted to kind of build a little worldview of this to help describe it. So here are our statically typed languages, right? And we said in the last lesson that in statically typed languages, all variables and parameters and functions need to be associated with a type. And so this is the case for all of these languages here, C# and Java and C, C++, they're all statically typed, and that is true for all of them. And then on the other side of the aisle, you have your dynamically typed languages, namely Python, where most people are coming from, but also JavaScript and these other languages where you don't have to tell the programming language what type of data you have in a variable. The program will figure that out at runtime. So for the purposes of this course, we'll say there's a hard divide between statically typed languages and dynamically typed languages. Now, whether those programming languages are object-oriented or not is another question on top of that. So in the statically typed world, we of course have Java and C#. These are classic object-oriented programming languages, but we also have those in the dynamically typed world. So Ruby and Smalltalk also are object-oriented languages at their core. And in fact, Smalltalk here, it's not a very well-known language, but it's considered the original object-oriented language. So a lot of the principles of object-oriented programming come from this language, Smalltalk. Okay. Now, with a lot of things, there's a gray area. So whether Python or JavaScript or C++ are object-oriented is somewhat controversial. So you could make the argument that Python does have support for object-oriented programming, and you can write object-oriented code in Python. But in my experience, students who are taking this course have not used Python for object-oriented programming. They've used Python more for procedural or functional programming or some other programming paradigm and not object-oriented programming. So that's what leads me to say that Python's really not object-oriented. Whereas object-oriented programming is quintessential to Java and C# and Smalltalk. You cannot write code in these languages without accepting object-oriented programming, whereas Python has some flexibility there where you don't have to write object-oriented code. Okay. C++ is kind of there's similar arguments. It's object-oriented programming is a complete afterthought when it comes to C, and C++ kind of just tacks it on at the end so that you can do some object-oriented programming in C++. Whether it's purely object-oriented or not is going to be dependent on who you're asking. Okay, and of course there's languages that are definitely not object-oriented. So C, for example, we use C particularly for operating systems code, really low-level code, and it's definitely not object-oriented. And Haskell, F#, Lisp, these are functional programming languages, so they also are deliberately not object-oriented. Okay, so with that, I'm going to run through some of the basic language control structures in Python and in C#. I'm assuming you've been exposed to these control structures, such as if statements, while loops, for loops, Foreach loops, functions. I'm assuming you've been exposed to those in the previous programming course you took. But we're just going to kind of run through these and note the syntactical differences between Python and C#. So here's your if statements here. These are logically equivalent, but in C# we have a parentheses around our conditional, the thing we're trying to verify is true or not. And there's no colon here at the end, as there is with Python, but what we do have is these curly braces here. So the code that we want to execute if this conditional is true is placed in between these curly braces here. And that's how we write our if statements here in C#. Okay, while loops, similar story here with the parentheses here. So we have to wrap our while loops condition in parentheses. But for example, in Python, we have this not keyword. We can say while not done, we want to execute the instructions in this loop. In C# we don't use the word not, we use this exclamation point. But it reads the same either way. While not done, we want to do things, and the things we want to do should be placed in these curly braces here. Okay, for loops. So in Python, your for I in range syntax here, this will print 0 through 9 in Python. For I in range 10, I will be 0, then 1, then 2, all the way to 9, right? And in C# we got a lot more syntax going on here. So we have these parentheses, and in this parentheses we kind of got this weird structure here, but we're going to read it in a weird order too. So how we should read this is consider a variable I whose initial value is 0. Every time this loop runs, we want to add 1 to the value of I, and we want to keep doing that until I is no longer less than 10. Okay, so it's kind of left, right, middle reading this. And the instructions for the loop here are in these curly braces, of course. So now we'll talk about lists. So I assume you've used lists in Python before. So you can create a list and give it some initial values, and you can read items in the list using the square bracket notation and the index. So this statement will change item 7, or will change the 7 to a 15 in this list, and you can append items to the end of the list, add items to the end using mylist.append, and then passing in the item you want to add to the end. So I assume you've seen that before. In C#, we have two different constructs. We have the array and we have the list. And there's a few differences between arrays and lists, but what I'll say for now is that arrays are fixed in size. So when you create an array in C#, you have to tell it how big is this array, how many items does it hold, and once you tell it that number, you cannot add more items at the end. Whereas lists, just as in Python, are flexible in size. You can add items on after you've created the array. So we'll start with arrays here. So what I said is still true. Variable has to be associated with a type, but we'll see we kind of have two types here. So the square brackets denote that this is an array. And in particular, we need to say, not only is this an array, this is an array that holds integers. So it's kind of a composite type. So you can read this, my array is of type integer array. And you can give it some initial values using this syntax here. And you can index it in a very similar way as Python. Zero-based index using that square bracket notation to change a value. Okay, so now lists, we have a lot of syntax going on here. So the list itself is a type. It's an object. And it again is kind of this composite type where we're saying we have a list, but we also need to say what kind of data is this list holding? Is it holding integers? Is it holding strings? Is it holding groceries? What is in this list? So we read it, my list is a variable and its type is a list that contains integers. And here on the right side we have similar stuff here, but we also have these parentheses. We'll talk about what's going on there in the future. And we also have this new keyword, and the new keyword is how we say, I want to create a new object, right? So on the left side, we're just saying, this is the type of this variable. On the right side, we're saying, I actually want to create a new list or a new object. And then we can give it some initial values here at the end if we want. We don't have to include this part here on the right with the curly braces. But we do need that semicolon regardless. Okay. This is similar here. And then adding on the end looks like this. So .add, mylist.add instead of mylist.append. Okay, Foreach loops. So Python, you have your Foreach loop. So if you have a list and you want to kind of go through each item in the list, you use this syntax here, for element in my list, and then you could print that element, for example, or do some other things. In C#, we use the keyword for each, and we have parentheses around this kind of syntax here, but it's the same idea. We have a list, and while we're going through the list, we're going to put each item in this variable called element, but of course we have to say, well, element in this case is of type integer, right? So presumably my list is a list that contains integers, and then of course the code we execute is in the curly braces. Okay, so now the big thing here is scoping. So in Python, scoping is done using indentation. So here's your Python program. So these are some number is defined on the outermost level of indentation, and so it's accessible to all the further indented code, as you know. But in C#, we don't use indentation as kind of a means for scoping. We use the curly braces. So some number is outside of everything, so it is accessible to all the stuff inside. But for example, J here, J is in the curly braces of the for loop. So it's not available to the if statement or to the rest of the program. It's only available to the inside of this for loop. Same thing with some text here. Some text is available to anything that's inside these curly braces of the if statement, but it's not available once this if statement is over. Okay, so this is a big difference. Indentation is not how we scope, it's with the curly braces in C#. Okay, functions and methods. So Python, you have your functions, and if your function is returning a result, so add numbers, takes two numbers in, adds them, returns the result, you just put that keyword there, return result, and you get that back to whoever called that function. And if your function doesn't return anything, for example, in this it's just printing to the console, you just don't put this return word here. You just do whatever you were going to do, and don't return a result. In C#, now functions and methods deserve more attention than this slide will have. But just to give you an idea of the typing, go ahead and ignore these public static words. Ignore public static, ignore public static. Start reading this here. So functions also need to be associated with a type in C#. So add numbers returns an integer. That's what we're saying here. So it has two integer parameters. Number one is type of integer. Number two is type of integer. We add them together, and then we have to return an integer. We can't return a string. We can't return a double. We have to return an integer because that's what we said directly to the left of the name. And if our function happens to be a function that is not returning anything, for example, it just needs to print something to the console, you still have your input parameters. It can be, which needs a type, but we use the special void keyword here to the left of the function name. And the void keyword tells C# that this function does not return anything. It does things, but it doesn't return a result. And that's important for the person who is, not the person, but the piece of code that is calling this function. The code that's calling this function needs to know if you call this function, you will not get a result back. And that's what this void keyword is doing for us. Same thing with up here, a piece of code who calls this function knows that if I call add numbers, I am definitely going to get a integer back because we said that here in the definition of add numbers. Okay, so hopefully those last few slides are a good reference guide that you can refer back to if you need to review the kind of the basic language syntax of C#. But now we're going to kind of enter into this more conceptual discussion about object-oriented programming. So when we want to organize related data, what I see Python programmers gravitate towards, beginning Python programmers gravitate towards, is these Python dictionaries. So you have a variable, my dog. In particular, you have a dictionary, my dog. And you can add different keys to your dog and give it values. So you can associate things like a name, an age, and a breed, and vaccines to this dog. But there's kind of this slow looming problem that develops when you're organizing data in this way. And that's where object-oriented programming and static typing kind of work together to provide a solution. Now, if you don't see the problem yet, let me make that more clear. So here's that same dictionary, right? But now we've thrown on attributes of a rent payment and a car and a favorite book and dogs don't have rent payments, dogs don't have cars, but yet we have the freedom to add these different attributes to our dog, right? Because the only thing really establishing that this is a dog is the name of this variable. So this is the assumption of an object-oriented programmer, is that if you kind of grant this freedom to put whatever data you want on something, it's going to get abused, and data that's not supposed to be associated with this dictionary in this case is going to end up on it. Okay. So if you need to visualize that a little bit more, consider that you can create a variable called myDog that's a dictionary and has only dog-related things on it. But again, the only thing establishing that this is supposed to be a dog is the name of this variable, right? And we can assign this variable to another variable, and then now we don't have that name. Or we can pass this variable to a function, and once it's passed to this function, it's no longer called dog or my dog. It's called my parameter. And so over the course of a program that's hundreds to thousands to tens of thousands of lines long, it's going to be hard to keep track of what data ends up in your dictionary and what doesn't. So this is where objects and typing come into play to solve this problem. So we need a way to explicitly tell C# what data is supposed to be part of a dog, or what data can be related to a dog. Because we saw with the Python dictionaries that if you don't have a way to do this, you're going to get data that's not part of a dog in this unit. So we want to specifically tell C# what is true of all dogs, so that we know if we have an instance of a dog, it will have these pieces of data related to it. So the example here, we have 3 different dogs, Marley, Mando, and Abby. They have different ages, they have different breeds, they have different vaccines, but what's true in general about these 3 dogs is they all have a name, an age, a breed, and vaccines. They're different names, different ages, and different breeds, but they're going to have a piece of information that denotes their name and age. So to express this, that we want to define what a dog is and what's true about dogs in general, we create a class in C#. So this is what this says the same thing the last slide said, except in C# and in a little more precisely. So we can see a dog. So we have to give our class a name. The class is dog. A dog has a name, an age, a breed, and vaccines, and a name is specifically a string, an age is specifically an integer value, breed is a string, and vaccines are a list of strings. So the typing, it needs to be here as well. And kind of to break it down a little bit further, I have this diagram here. So class is the special keyword here that says, hey, C#, I'm creating a class to describe what is true about all dogs. What do all dogs have? So, you can pick your own class name if we're doing cats or bank accounts or whatever. And these items, each of these items in this class is called a property in C#. This whole thing collectively is called a property. Age is a property, breed's a property. And there's an access modifier. We'll talk more about that in the future. Generally, for properties, it's always going to be public. Your properties are always going to be public. We'll have a different term for things that are private, and we'll talk about the difference between public and private in the future. This thing at the end here, this little get set thing, if you've done object-oriented programming in Java, then you probably have an idea of what this is. But for now, we can think about it as a way to say, are you allowed to read this data, or are you also allowed to change this data? So because name is get set, that means if we have a dog, I can read what its name is, and I can also change the name of the dog. So that's what these are for. Okay, so we've written our class, and now we actually want to use it to create dogs. All the class does is describe what's true about dogs in general. Okay, so here's an example program using that class. So now we can create dogs, and you see you create a dog, has the type dog to the left of it, and you can set the values for the properties that relate to this dog. Okay, you can create two different dogs here, different values on those properties. And you can read these values back later in the program, so that's what we're doing down here. You're saying I have two dogs with their names, and we're saying we're calculating the average based on the age of these dogs here. So, right, this is our unit of organizing data, creating these classes to say what the data is, and then once we've done that, you can create these objects like so. And so the important part here is you're not going to be able to go dog1.carPayment, dog1.favorite book, because that's not part of the class we made. Okay, so if you've done Java before, this might be how you're used to setting up your classes. If you haven't done Java, just ignore this slide. But for those who have done Java before, this is the equivalent of what we just did in C# in Java. So you create these private fields, and they have getters and setters to get the value of the private fields and set the value of the private fields to new values. And as you can see, this is much more verbose than C#, right? I can't even fit the whole class on the slide because there's too much syntax here to do so. So I think this is one of the big improvements of C# is that we can say the same thing we can in Java, but we can say it much more concisely. And of course, a Java programmer, someone who likes programming in Java, might say there's a good reason for why you have to do it this way. But from the perspective of a C# programmer, we like how we're doing it because it's shorter and more concise and more productive. We can get something typed up quicker than we can in Java. Okay, so moving on, we want to talk about attaching that functionality to these objects. And when using Python dictionaries, there's not really an equivalent to this, but I'll kind of show this Python example just to warm you up to the example we'll show in C#. So, pretend you have a dictionary called myTriangle, and it has side 1 and side 2, and you can send this dictionary off to a function here, off to this calculate hypotenuse function, and it'll read the value of those properties and calculate the hypotenuse here and return you the value. Okay, and you can print that out or do whatever you want with that. So this should be familiar to someone who's coming from the Python background. Now, if we want to do this in C#, we kind of think about it a little differently. We want to think about it in the sense that, say we have a class of right triangles. So all right triangles have a side 1 and a side 2. Now, calculating the hypotenuse of a right triangle is something like quintessential to right triangles, right? If we have a right triangle, this is something we're going to want to do with it. So any of these kind of functions that are inherently part of your classes should be defined in what we call methods on our class. So this is a method, okay? And so calculate hypotenuse returns a double, and it's a public method, and this is our implementation. Now, you can see in Python we had to pass in the dictionary as a parameter to it as a function, but as a method, we have access to all the data that we know to be part of right triangles in general. So we can say, you know, if we have a right triangle, a specific right triangle with then in general we can say you just take the side 1 and the side 2, add it to you take the side 1, multiply it by itself, take the side 2, multiply it by itself, add them together, take the square root, that will give you the hypotenuse. Yeah, so we're describing this calculation in general. And so when we go to use this method now, it looks like this. So you create the right triangle, you set its values, and then you can go triangle.calculate hypotenuse. And so, and this, based on our implementation, should return 5, right? Okay, so if you can see, the data is not like being explicitly passed through the function as a parameter. It's because this method is operating in the context of this triangle that we set up. It's going to know that, well, the value of side 1 of this triangle is 3, the value of side 2 of this triangle is 4, and it'll use that when it performs this calculation here. If we had a different triangle with different values, of course, it would use the values that were associated with that specific instance of a triangle. Okay, so with that, we'll transition to a demo. Okay, here is the description for the lesson 2 exercise. Because it's based off of the lesson 1 exercise, which I did not get in the video version of the lecture. I only did it in class. I'll kind of just show the video 1 exercise here to give you a sense of what it was. So I mean, all it was a short program that asked the user for the size of a dice, and then did some validation to make sure it was a valid size for a dice, and then it rolled the dice, so selected a random number between the 1 and the value of that the user entered. Okay, so that was all it did. Pretty simple program, and what we're going to do to meet exercise 2 is I will go ahead and create a new project in Visual Studio. And we want to create a console app, and I'll just call this exercise 2, and next, and I'm going to do .NET 7 here, and I'm going to keep this checked here. Do not use top-level statements. It might be unchecked for you if this is your first time creating a project, but I like to keep this checked. Okay, so I'll just create that, create this project here, and what we'll do, because we haven't gotten into using Git and Azure DevOps yet, I'm just going to take this code here from the exercise, and here's our new project, and I'm going to paste it in here, and we can go ahead and run it just to see what it looks like. Okay, enter size of the dice, you enter 6, the dice rolls a 3. And if you enter something that's not a valid number, it tells you that as well. Okay, so that's just because we didn't get a video of exercise 1. So now exercise 2 is given exercise 1, we want to refactor the code so that we're using an object instead of kind of this loose code in our main program here. So in particular, we'll be creating a die class to describe what should be part of a die, and we'll add a method to that die called roll that will generate the value of that dice. Okay, so to do that, I have this up in Visual Studio, and I want to right-click. So here we have a couple levels here, a couple levels of hierarchy here. So on the top of the hierarchy is the solution, and the solution contains projects. So the name of our project is exercise 2. As well as the name of the solution. And within a project, you have C# files. So if I close this window and I pop it back open, right, this file goes to this code here. Okay, so now I want to add new code here. In particular, I want to add a die class. So I'm going to right-click on the project and do add class. Okay? And I'm going to call it die here. So just type here. I'll do that again. So add class. There's more than just classes you can add, but in particular, we want to make sure class is selected up here, which it should be if you selected add class. And then here's where you give the class a name, and I would overwrite what it says here with a good name for what you're describing here. Right here, we're describing what's part of a die. Okay, we click add, and then we get a new file that opens up here. Okay, we can close it, and we can open it, and we're all good. Okay, so now we want to create that property that's part of a die. So a die should have a size, right? So public int size, then the weird get set thing. Okay. So that's it. That's how we say that dies have a size associated with it. And now on this end of the program, what we want to do is we want to take what the user inputs and then create a die. So die, my die equals new die. Okay, so that creates our new die, and we can go my die dot size, and then we can set that equal to the value that the user entered. Okay, so now we could right here. So instead of using number as int, right? This is our old way of our old variable we used. We could do my die.size here, right? This should be pretty clear because we're setting my die.size equal to what was just there. Okay, so now we're doing this. We're simulating a roll right here. We're using a random object to roll the die, and we don't want this to be loose out here. Rolling a die is something that is inherently part of being a die. Okay, you're meant to be rolled. So I want to cut this code here, and I want to create a method on a die. Okay, to describe this functionality here. So my die int roll. Okay, and I want to paste that in here. So now this is so my die was the name of our variable out here. But from the context of a class, we're talking about a die in the abstract. So typically, what you do for that is saying this. Okay, so that's saying whatever the current die is, whatever that is, use the size of that die. Okay. and you can roll it, and then you'll see it's complaining here, and it's saying die.roll, not all code paths return a value. So because the type of the method is an int, this is not going to work until we return an integer. And in fact, if you try to run this when that's the case, it's not going to work. It won't open that window. It's going to say you have issues in the code. You said roll returned an integer, and you're not returning an integer. So we can just do this, but there's still an issue. So next int 34 or 64 returns a long, and we're saying this returns an integer. So we can fix that by casting this right here, and that should take care of that. So this is our implementation for rolling a die. Okay, so now what we can do here is something like my die.roll. And that's it. This should work the same. Dice rolls a 7. Dice rolls a 4. Okay. So that's the first part of the exercise. We just kind of moved some of the code that was in our main program over to this die class. Okay. So now, second part of the exercise, we want to allow the user to enter how many dice they would like to roll. And then we want to create a list to hold these dice, and then we want to roll all of them using a for each loop. Okay, so let's see that. So first thing we got to do is ask the user for another piece of information. So enter how many dice do you want? Okay. Okay, and this will look similar to what we just did here. But now we have this validation here for the first piece of information we asked. We wanted to make sure it was a valid integer. Okay, so we're kind of duplicating code right here to make this work. So you can see this does the same thing what we just had. It'll ask you how many dice you want, and we'll have to validate it. But this code is almost exactly the same thing as this code here. So what we're going to do, because we don't like duplicating code, is we're going to create a function to kind of ship this off in its own set of logic. So we haven't talked about the static word yet, but for the sake of this demo, just write it, and we're going to create a static function called ask, or we're going to call it get integer from user, and that's going to take in a string called prompt, okay, and return that integer. So we're going to do the same thing here that we do up here. Console.write, and then we want to write the prompt, and then string input is console.readline, and then the validation logic, I'm gonna copy this, paste it down here. So we're going to do the try parse to validate that it's a valid int, And if it's not valid, we're doing that environment.exit. We're just giving up. If it is valid, we want to return the value that got returned here. Number is int. Okay. So now we're still getting an error here. Get integer from user, and it's saying not all code paths return a value. So it's complaining because this if statement doesn't have a return statement. Okay, but we're literally terminating the program here. So you'd think we'd be all right to just terminate, but it's still gonna insist that we add a return here so that if you call get integer from user, you are guaranteed an integer back. So I'm just going to return -1 if that's the case here. Okay. So now we have this nice function here, and we're going to use that instead of doing that multiple times in our main function. So we should just be able to do something like int dice size equals get integer from user. And this is kind of ad hoc validation here, so can't be less than 2, so we'll keep that there. And we'll do the same thing here. So int number of dice equals get integer from user. And then we can delete all this, and then it's a little bit simpler. Okay, so that was the first part here, right? A lot of refactoring to just make this code look a little cleaner. So, what we want to do now is we want to create that many dice and put it in a list. So once we know how many dice we want, we can do a list of dice equals new list of die. And we can do a for loop for int I equals 0, I less than number of dice, I plus plus. We can do dice dot add new, sorry, I'll break this out a little bit. We can essentially do this here. Okay, and I have the wrong value here. It needs to be dice size here. All right. Now you'll see my die doesn't exist anymore because we've moved it to this for loop, so it's out of scope here. Plus we have multiple dice, so now that's not going to work. All right, so this is going to create that many dice and put them in this list. So now, if you want to inspect this, you can run it. So right now we're not rolling any dice, we're just kind of building them. You can use the debugger, and the debugger is going to freeze the code at this line of execution. So how big is the dice? It's 6. How many do we want? I don't know, maybe 20. And you can see the program froze right here. And we can create this list, click F10 to go to the next, or maybe I should describe it up here. Let me do that. So how big is the die? 10. How many you want? 20. So up here you have some debugging controls. So because we put this breakpoint here, by clicking on this bar, you can step over or step into the next line of code. So in the case of this code, we want to just step over. That means it's just going to execute this line of code, and you can inspect again after it. So after I execute this line of code, you can see we have our variable dice. It's a list, and it contains 0 dice. And now we can step over and create a dice here. So its size is 0. Its size is 0 when we first create it, but we see dice size is 10. After we execute this line of code, my die dot size is also going to be 10. And then we can add it to this list. So step over, and dice dot add is going to be now in this list here. So our list now has a count of 1 because it contains this die. Okay, and let's step over again. So now we're executing I++ to add 1 to I. Step over. We're going to keep going because I is still less than number of dice. We're going to step over, and we're going to create another die. And we're going to set that die equal to that same dice size. And right now, the die is not added to the list, but once we step over, we're going to go dice.add my die, and then you'll see now there's 2 dice in the list. Okay, so we can run the rest of this loop just by putting a breakpoint before the end of the program and clicking continue. And now if we look at dice, we can see there's 20 die in here. All of them with size 10. So that's an example of inspecting the code with the debugger, because if we didn't have the debugger, we wouldn't be able to see anything right now, right? Because this is still our window. And so if I just continue, the window doesn't print anything. Okay, but now let's do that part. Let's add a for each loop. For each die in dice, we can go console.writeLine and die.roll. Or, you know, if we want to split it out, maybe we could do this. Int result equals die.roll. And we write the result. Okay, so now I can run this. Okay, so it rolled the 7 dice, and here are the values there. Now, let's use the step into in the debugger. So let's put a breakpoint here on line 26. Run the code, right? It's going to first ask me the question, how big is the die? 10. How many do you want? 20. Okay, now it freezes right here. And we haven't rolled the dice yet. There's nothing in the result yet, or what I should say is what's in the result is the default integer, which is 0. But we can use step into right here, step into, which is F11 for short, and that is going to take us to the roll method. Okay, so that's what step into. Step over just says, I'm just going to execute this line of code, and we're not going to jump around. Step into is going to bring us to whatever code that's being executed. So we stepped into the roll method, and we can see that we're in a die right now, and we can execute this line here using step over, And you can see we're referring to this dot size, and we can see this dot size is 10. Now, not all die will have a size of 10, but I suppose in the case of this example, they all will. But just know that this dot size is just whatever die we stepped into is the value of size we're going to be using. Okay, let me step over. After the method we stepped into is over, we're going to be taken back out, and the result will be available here. Apparently we rolled a 10. Let's do it again. So we continued. We're in the next iteration of the loop. Step over. All right, now we rolled a 4. All right, good. All right, and here it is all printed out like that. Okay, so that's it for the exercise. Just a very simple example of moving some code into an object, and also using some of these control structures, and using a method and using the debugger.